welcome to another episode of Property Talk with Monica. My name is Monica Chen. I'm the owner and managing director of Uno Property Management. We're based in Mount Eden. Now, with us today is Andrew Clark from MV Engineering. Hi, Andrew.
Hi, Monica.
You are a structural engineer.
That's correct, yep.
Very exciting job. Now, we're here to talk about earthquake.
That's right.
So, is it the main part of what a structural engineer does?
Yeah.
Tell us about how do we keep our buildings from collapsing in an earthquake in general?
Yeah, so many people might not realise, but we spend most of our time as designers, structural designers, making sure your buildings don't collapse in an earthquake. So I thought, Monica asked me to talk about it today, and I thought I'd just add a bit more about what we actually do to make that happen. So to begin with, I thought I'd start talking about where and why the earthquakes happen in New Zealand. So most of you may be aware New Zealand's on a very large fault line that runs from sort of Napier through Wellington across down the Southern Alps. Mm-hmm. So the closer you are to that, the larger the seismic force. So to give you an example, Wellington has roughly 4 times the earthquake load that you would get in Auckland. So that makes a big difference. We're also in the process of changing those loads, so the Wellington ones may in the next coming years almost double, which is massive. Auckland will go up as well, but probably not by as much. So there's some big changes. How does it double? So the last time they figured out what the loads were was 20 years ago.
Right.
And since then they've done a whole lot of research, they've done a whole lot of testing about our fault lines, analysis, and they've brought that all together and looked at what overseas is doing, and they've republished what's called the National Seismic Hazard Model.
Right.
And that has laid out the new design loads we are going to have to design to.
So what we're saying is our capital city is in a very earthquake prone.
It is, yeah.
City.
And it could get worse.
Right, and the real estate price there would not be doing too well, I don't think.
No.
All right, going back to earthquakes.
So that's the first thing, is how close you are to the main fault lines. The second is what sort of soil are you sitting on. Generally speaking, this isn't always the case. If you're on very soft soils like a peat or a sand, they have higher earthquake loads in them because they allow the building to shake more, whereas rock doesn't have as high earthquake loads. That is going to change slightly in the future, but to keep it simple, that's what we'll talk about today. The other thing that we do is we take into account the importance level of the building. So what that means is how important is the building to society. So for a hospital or something that has lots of people congregating, like a church or a large hall, we design it for 30% more load than a normal building. The height of the building obviously has a big impact. So the higher the building, the higher the earthquake load. The other thing just to remember is that if you are twice as tall, it doesn't mean you've got twice the load. It actually ends up as more like 5 times the load because of the way earthquakes work and make the building shake. The other thing is, what is the building made out of? The more you let a building sway, that might be a steel frame or a timber building, you actually end up with less load in it because the energy of the earthquake is being dissipated. So these are some of the key things that we're thinking about as we're trying to design to resist earthquakes. And so one of the key things that is happening in the industry is there are new products coming in to make the earthquake resistance a bit more intelligent.